Control Tray. Together we are the USB Scavenged Power. And the motivation for this project was to explore the sources of otherwise waste and ambient power that you would find in a typical suburban home, and find a way to generate enough power density out of those to charge one or both of our cells. So, you obviously, there's products out there that do this. You've seen a backpack with solar cells that will charge your iPad. What we wanted to do differently was to make it a modular system so that we have a control box and we have a number of very cheap, very basic peripherals that actually do the harvesting and feed control. So the control box, what we decided to do is go with the linear technologies line of step up and step down for their high efficiency, and the TI, the MSP 430 line for their also very low power consumption for control and monitoring. Now, the reason for even using a microcontroller really in this project is to give the control box so that it's not just a brick that you plug in and walk away from. Give it some monitoring so you can look at it and see, if I move my peripheral over here, if I do this with my peripheral, am I getting more or less power, and let it be almost a way to learn about it as well as just a black box that collects energy. So the controller will also store the power in a lithium-ion battery and return it to USB specifications to charge it on. So the peripherals, we looked into a number of different peripherals. The idea being that you could take a wide variety of peripherals, need no particular input management from them, and just plug them directly in and let the control box do it. So we looked at telluric batteries, which are an older idea that used to be used in telegraph, power telegraph. We looked at thermoelectric generation and hydroelectric generation, of course, a basic solar panel, piezo. The two that we decided to focus on for our particular demo, so we don't end up with a bit of scope creep, is a TEG, which we are going to attach to a small evacuated solar tube, right, to generate the high end, and then put it in a floating heat sink that you can set in a swimming pool. Our tests of that have shown that gives us enough delta T to get roughly 250 milliamps out, which is a reasonable number for a small tank. And then also we're building a small turbine that snaps on the bottom of a typical kitchen faucet, much like your pure water filter, and will collect water power while you're running your water to drink or eat or cook or whatever. So those are our two peripherals. As we go further on, we may expand these peripherals to use other options, but those are the two that we will demonstrate at the end of the semester. So by the end of next semester, we will have a box that collects the power, stores it, outputs it, tells you what you have collected, and two peripherals to test. That'll be our goal. Any questions?
So the faucet thing is interesting. So it's basically, it's got the battery built into it, so when you pull it off the faucet to charge your device, or would there actually be a wire that comes off its charging wires?
There has to be a little wire that comes off. So you set the device up on the counter out of the way of your faucet, and it'll just snap the bottom of the faucet.
Because I guess a lot of people have already put like a filter on their faucet, and so integrating with something like that, maybe even with a battery you could just plug into, could be kind of interesting.
The system has a lot of components. What is it that you are going to actually build? What is turnkey? Also, energy harvesting, since you are using multiple components, isn't the actual system performance will depend on the environment you are in? You may be where the light is not there, you may be where the temperature is not, difference is not enough. So how do you adjust for that? How would you actually program it so that you are going to do it at an optimum efficiency or optimum performance level?
Well, we're letting some of that be controlled by the user in the sense that if you're in a place where you don't have a way to make a thermal variant, you can plug in any other type of small, cheap peripheral. The idea is that you can buy more than one peripheral because that will be the simplest, easiest part to get, and then the control module will control that.
So the system is a control, the other components are plug-in.
Correct. Yeah, they plug in with just a standard.
That was not clear.
What kind of turbine are you planning to put in the water pipe?
Yeah, that's a very interesting question. The component I found actually comes from a company called Ridge Street Toys. They have this really cool hydrodynamic set that you can buy for about $90. Excuse me, through homesciencetools.com, I believe. And it comes with like a fountain pump, and it's got all these girders and all these valves and things. It's actually a lot of fun to play with. But one of the things I found in there is it's actually got an enclosed little paddle wheel with a shaft through it. So basically what you do is just drill through that shaft, take another, like go to a hobby store and you just use your caliper to get the right size shaft. You get one that's longer so it extends out beyond the housing. Maybe put a couple, water resistant washers on the outside. And then Tins and Cosmos also makes some kits for wind power and water turbine power. That basically they're like these very like DC brushless motors that have almost no friction. So you can just sit there and spin it, and you can actually plug an LED into it and get an LED light.
But are you going to put the turbine inside the pipe, or is it going to be a diversion outside?
Great question. Yeah, so you can do both. The first thing, of course, I'm going to do is put it just right up to the faucet, because that's the easiest thing. But the natural extension is, what if in the future we could take like a module that goes like to your water main, and as the water pressure is coming in, as you're using water, you're always generating electricity. Does that kind of answer?
Yeah, there was a middle school project in the science fair last week.
Oh, okay. Well, beat me to it. What can I say? What by the seventh grader?
Yes.
How about these it sounded like a type cell with a temperature differential, but it looks like a photo cell. What is it? Is it sun or temperature?
The particular tag we're using is going to be temperature. You're going to be able to plug in any type of small peripheral that you want. So the particular one of the two that we're demoing is a tech, yes, a thermocell. Okay. If we're successful at that, we may try and build more peripherals just to test them and see what kind of power we get for each one. But that's the two we've been